Hello everyone. Today we are going to study about thermodynamics. In this chapter, we'll let you know about all the systems of thermodynamics and then we'll know about the laws of thermodynamics. So before going to that, we'll discuss what is the definition of thermodynamics. The branch which deals with the movement of energy from one form to the other and the relation between heat and temperature with energy and work done is called as thermodynamics. In other terms, we can define thermodynamics as a science stream that deals with the study of combined effects of heat and work on the changes of state of matter confined by the laws of thermodynamics. Chemical reactions which release heat energy associated with it are converted into different usable forms based on the laws of thermodynamics. The fact that energy can only be transformed from one form to the other forms and its use in different industries is on the basis of energy transformation. We are aware that chemical reactions have energy associated with it. Now, let us know about the various thermodynamic systems. First one is open system. Those systems where the exchange of energy as well as matter takes place are treated as an open system. For example, water is boiled on a stove without it being covered. The container behaves as an open system because it receives heat energy from an external source and the matter being released are water vapors. So the image says it all. Then the second one is closed system. A closed system is referred to the system where only energy can be exchanged with the surrounding and not the matter. It can also be said that a closed system has a constant amount of matter and only the energy of the system can be changed. For example, when we keep a sealed bottle of water in the fridge, the loss of energy into the surrounding will result in the temperature of the water inside it going down, even though the quantity of water in the bottle remains the same. Then your third one is isolated system. In case of isolated systems, neither energy nor matter can be exchanged between the system and the surroundings. So the best example of an isolated system is a thermos flask. Now we'll discuss about the various laws of thermodynamics. The laws of thermodynamics deal with energy changes during a reaction and are not concerned with the rate at which the reaction is proceeding. So, your first law of thermodynamics is when energy moves into or out of a system, the system's internal energy changes in accordance with the law of conservation of mass. So mathematically, delta Q is equal to delta U plus W, where delta Q is heat given or lost. Delta U is the change in internal energy. W is the work done. We can also represent the above equation as follows. Delta U is equal to delta Q minus W. So, this is your first law of thermodynamics. The second law of thermodynamics says that there is always an increase in the entropies of all participating bodies when any real process takes place. The second law is basically about the thermodynamic radiation of bodies and matter, which is in its thermodynamic equilibrium at first and are separated by the walls which allow or resist the passage of matter and energy. So, the best example of second law of thermodynamics is a heat reservoir. Heat reservoirs are basically of two types, high temperature heat reservoir and a low temperature heat reservoir. Sometimes heat is transferred from a high temperature reservoir, that's why it is called heat source. The heat transferred to a low temperature reservoir is called heat sink. Then the second one is work reservoir. Work reservoir is a big system and which has a stable equilibrium. It can allow the transfer of the finite amount of energy without the change in pressure. Now, the third law of thermodynamics states that the entropy of a perfect crystal at absolute zero temperature is exactly equal to zero. The most significant use of the third law of thermodynamics is that it helps in calculating the absolute entropy of a substance at room temperature. These determinations are based on the heat capacity measurements of the substance. So what is entropy? Entropy is the measure of disorder in the universe. So the higher the entropy, the higher the disorder. So going back to the third law, it says that entropy at absolute zero is zero. In other words, things are most orderly when they are really cold. Absolute zero is the temperature at which molecules stop moving or vibrating at all. The complete stop in molecular motion happens at minus 273 degrees Celsius, which is defined as 0 Kelvin or absolute zero. So at absolute zero, that is 0 Kelvin, the system is said to possess minimum energy. This statement of the third law of thermodynamics holds true only when the perfect crystal has minimum energy state. If the system has minimum disturbances, it means that the temperature has approached 0 Kelvin, where molecular motion ceases to exist. Standard molar entropy is defined as the entropy per mole of a substance at standard conditions and specified temperature. Then the last one is zeroth law of thermodynamics. According to zeroth law, if two bodies, that is I and double I, are in equilibrium with a body triple I separately, then it follows that body I and body double I are also in thermal equilibrium. As no heat flows from I to triple I, hence Ti is equal to T triple I. Similarly, T double I is equal to T triple I. It follows that Ti is equal to T double I. Hence, no heat flows. Zeroth law of thermodynamics is based on thermal equilibrium. It is defined as a situation in which no heat flows from one body to another when brought in contact with each other. In other words, the parameters of the system like volume, pressure, temperature or composition does not change. As heat does not flow, we can also say both bodies acquire the same temperature at equilibrium. So guys, we just discussed about all the laws of thermodynamics. For detailed study of this chapter, you can go through our website www.syft.in. You can write to us if you have any queries. Thank you.